coming to this talk. I was expecting an empty room, taking a picture and doing some Photoshop, but I appreciate you all being here today. I hope you had a great day yesterday. I surely had. And thanks for joining me to talk about TypeScript. But before we start, I just want to get a sense of the room. Let's do some show of hands. Raise your hand if you're a Java developer. Cool. Right audience. And raise your hand if you use JavaScript as well. Okay, keep your hand up. Keep your hand up if you like JavaScript. Oh, that's good, that's good. A good mix, a good mix. Well, TypeScript helps in this situation, especially for Java developers JavaScript, front-end development, and sometimes even back-end development. There's no way around it, right? The vast majority of front-end applications are made with JavaScript. So it's something that at the end of the day, we need to interact. But I know we miss a lot of things from our good friend Java, right? And hopefully, you can get a sense of TypeScript and how it solves some of those issues. And I understand that we're all busy Java developers, and we need to keep up with just within our ecosystem, right? There's always a new framework, new library, new way to deploy something to the cloud. So yeah, we're busy. And sometimes we don't have time to explore what's outside and what other ecosystems are doing. So yeah, the purpose of this talk is just to bridge that gap. A little bit about me. My name is Orlando Valdez. I'm a software engineer at Credit Karma. I'm also a Java developer, just like you. And I've had the pleasure to working with other languages as well. So I've been working with TypeScript mostly on the back end for the last 2.5, 3 years. So yeah, I can give you a good perspective of the things that a Java developer will enjoy. And like any other languages, there are good and bad for any languages. I'm also the co-organizer of the Charlotte Java user group. So if you are in the area or you're just passing by, feel free to drop by to any of our events. You can reach out to us there. A little disclaimer, I have just a few slides, a lot of code, and very, very little time. So I'm gonna go fast on the things that, you will see that there's a lot of similarities. The syntax is very similar to Java. So I'm gonna skip through those things that are really, really basic. And I'm gonna slow down on the things that I really find attractive for a Java developer when it comes to TypeScript. So let's start with what is TypeScript. TypeScript is a type superset of JavaScript. That means that any JavaScript program is a TypeScript program. You can just rename the extension and run it through the TypeScript compiler, and you probably won't have any issues, but it's not the other way around. You cannot run a TypeScript file in a JavaScript runtime because TypeScript adds a lot of constructs that are not valid in JavaScript. It was developed and is maintained by Microsoft. There are other collaborators, contributors as well, like Google, but initially it was developed there. It transpiles to JavaScript using the TypeScript compiler, TSC. This is just like our JavaC, but instead of bytecode, it generates good loved JavaScript files. It also provides language services through the TypeScript standalone server, or TS server. So these two components, compiler and TS server, are the things that you get installed when you say that you install in TypeScript. You get these two things. You usually don't interact directly with the TS server. The TS server is for your IDEs and code editors to integrate, and you get all the benefits of a rich support, right? Like refactoring, autocomplete, and all the good stuff that we're used to with Java. TypeScript files have a TS extension instead of a JS extension. And it has an awesome type analysis system that we're going to experience here through the code demos. How do we install TypeScript? You can install it if you're using Visual Studio Code. You can install it as an extension. Or you can use NPM if you're on a Mac or Linux. You can use Nugget, I think, on Windows. Did the image went away? OK. So you can install it that way globally, so you can have it available anywhere, but usually you install it as a dependency in your project, so you can have different versions depending on the project that you're working on. How to create a new project. There's nothing special about creating a new project in TypeScript. You just need a tsconfig JSON file. with some compiler options. You can create one manually, or you can run the compiler with the init flag, and it will create one for you with some default settings, and it will show you the complete list of options that you can tweak. I just have a few examples here. For example, the target. This specifies what's your JavaScript target version. So depending if you're targeting a browser, you might use ES5 or ES6, depending on the minimum version that you support. And if you're targeting a no runtime, you might pick up something different. You can specify the type of module system you're going to use on your exported transpiled JavaScript. You can specify the root directory where all your TypeScript files will live. I mean, you can have a subdirectory tree there, but this is your root directory. And the out there directory as well. This is where all your JavaScript files will be stored. You can enable source maps. This helps you when you are debugging, because at the end of the day, you're not running TypeScript code, you're running the transpiled JavaScript. So this helps, these source maps helps your developer tools in your Chrome or your IDE for you to be able to map the running code with a line of TypeScript code, so you can put breakpoints and everything. You can use debugging sessions just like you do in Java. And then the last flag there, strict. Strict, it groups a lot of checks that makes the TypeScript compiler really strict. For any new projects, I recommend just to set it to true, and you will get the full benefit of the type system. But if you are migrating a JavaScript project to a TypeScript project, you can do that incrementally. So you can disable this flag and let the compiler be as loose as the JavaScript runtime. And then as you are making changes and adding types and leveraging TypeScript features, you can start adding more fine-grained flags that are available to make sure that you're following those recommendations. Okay, last two slides. This is really important because both JavaScript and TypeScript are, say, they have types, right? They have a type system, and that's what we like about Java, and that's what we miss when we're using JavaScript. But the type system is different. Let's take a look at one example. So here we have a class person and a class pet. They look pretty much the same, but they have a different name, right? If I try to create a variable and assign a reference to pet, the Java compiler won't let me do that because they're incompatible. And that's because Java uses a nominal type system, where every comparison, any compatibility is based on the naming of the things. So in this case, the class person has a person name. Want to get it? Oh, sorry about that. So it has the name of the class is person, and pet, the name of the class is pet. So that immediately makes them incompatible. Let's look at the same example in TypeScript. So here we have the same class, person and pet. I just added an additional property for person, just for another of the examples. But here, if we try to do the same, the compiler is fine. And this is because TypeScript uses a structural type system. So structural type systems doesn't care about the name. It cares about the shape, the properties of that object that you're passing. So in this case, pet is expecting an object that has a string property called name. And the person class has that. So it satisfies that requirement. So I can do that. I can instantiate a new person and store it in pet. I can also just pass an object. I don't need to instantiate something. I just pass an object that has the properties that person requires. I cannot do the other way around, right? Because a person is expecting two properties, a name and an age, and pet doesn't have age. So the compiler will tell me that the property age is missing. So this is a fundamental change to understand how TypeScript works, and that's even though that makes it a little bit different how we code, even though they both have a type system. Okay, so let's take a look at some code. Let me know if the font is big enough for the people on the back. Yeah, I said I was going to skip the basic things, but this is a quick one. Just how do we declare a variable? In TypeScript, we just use the let keyword. We provide a name, then an optional type. And we declare the type with a colon, and then the type, and then we can assign a value. This is optional, like I said, the type, because TypeScript has a really powerful type inference. In this case, for example, the compiler will know that this is a string based on the value that I'm assigning. This is how we declare a constant. So lets you mutate the value. If you want to make it a constant, a fixed value, then you use the const keyword. And in this case, the compiler will type to narrow as much as possible the type of the variable, well, or the constant in this case. And since a constant cannot change, it knows that you're not going to add a different number. So it doesn't specify the type. It doesn't infer the type as number. It infers the type as a literal number. In this case, the number 40, because you cannot store any other number. So it doesn't make sense to make it a number. This is just another example to define a string, being explicit about the type. You can have arrays. And you can have tuples. So tuples are like arrays, but they have a fixed number of elements. And the benefit is that you can add different types. So in this case, I have 3 elements in my tuple, 1 number, 1 Boolean, and 1 that has this shape, this object type. So I can store those things, and I can access them through the index. And finally, this is just a literal object where I can just create an object on the fly, and it will get assigned. And TypeScript will infer the type of this object to be one property string called name and one property number. It will infer the types based on what you're passing. Now let's take a look at some more TypeScript-specific types. So we have the any type. The any type, you can assign any value to the variable that you're creating with this type, and the compiler won't make any checks. So here, for example, I have 2 properties, foo and bar, and I'm assigning true to a property called OK. And there's no property OK here, but the compiler is fine because it's not doing any checks. This is just like JavaScript. Here I'm setting a string in what it was a Boolean value. So again, just like JavaScript. So obviously this is discouraged. Any is there. It will help you to migrate existing projects. But if you're creating a new project, stay away from any. There's an alternative that is the type unknown. So let's say, for example, you have a function that you receive an argument, but you don't know exactly what type of object you're going to receive. You could pick any, but then you run into all these issues because anyone can do anything with it. But if you use unknown, this is what will happen. The TypeScript compiler will allow you to assign any value. You receive that. The only problem here is that TypeScript won't allow you to use it until you narrow the type, until you really identify this object. So this avoids many errors because you have to be intentional. So here it's telling me that it cannot access foo because the object is of type unknown, and you cannot use it just like that. So one way to use it here is to cast it. This is, it's one of the many ways to narrow this type, but one simple thing is casting. So we use the operator as for casting, and we're saying that box convert this type of unknown to this type. And now I'm able to access that property without any compiler errors. Did he do it again?
It's been steadily like.
Oh man, I think it's my adapter.
It comes back after this 5-6 seconds. Yesterday's lecture also this screen has some.
Oh. Okay, let me know if it stays for long, and so I can pause. We have maps, just like in Java. You can start them with the generics key and value types. We have undefined and null. Undefined and null sounds similar, but undefined is the absence of something, and null, to use null, TypeScript will never assign automatically a null value. You need to be explicit, and you need to set it yourself. So here, one example is that if I have this object that has only one property of foo assigned to null, if I try to access bar, it will be undefined because bar doesn't exist, it's absent from there. Obviously, I'm allowed to do that because I'm using any as a type. If I was using an actual type, I wouldn't even be able to do that, to even try it. And then foo will give me null. So null, the developer will set something to null. Undefined, the TypeScript compiler will just give you an undefined because its property is absent. Void, just like in Java, if a function completes and you never return, then you say your return type is void. which is different from never. Never has its specific use cases, so you can use it in two contexts. In a context of a function, never signals the user of this function, that this function will never return. It will never explicitly return or complete. So in this case, we immediately throw an error, so this function never actually completes, but because it throws an error. For example, if you have an infinite loop, you can signal the user, hey, this has return type of never, so it will never return. Another use case for this is when we're doing type narrowing. I'm going to describe this in more details in the following code pieces, but just quickly, here in this function, we're receiving an argument that can be a string or a number. So if we exhaust the options and we narrow all the alternatives, then at the end, the compiler will assign a value of never, a type of never to the property. In this case, we're saying, hey, check if this value, it's a string, and then do something about it. Else if, check if it is a number, and then you do something about it. But we know this can only be a string or a number. So at this point in time, TypeScript is smart enough to say, well, this will never happen. So it stops you for using this value. You cannot use it anymore because this code path, it's unreachable. With TypeScript, you will definitely be able to use this thing and find out later at runtime that you got a problem. We have enums. By default, they're numeric. You can have them as a string. You use it very much like in Java. I don't use these enums a lot. We'll see another construct that gives you the same. You can express the same ideas without so much ceremony of creating an enum. Type aliases. So aliases are just a way to give a name to a property, to a type, sorry. So a simple example is that here I'm creating a type, I'm naming it ID, and this is just gonna be an alias to a number. So this can help me if I wanna express more my domain language in my code base, so I can do this. So instead of returning, asking for a number, I'm asking for an ID that gives you a better idea of what you're asking for. And it's pretty simple. But for all intent and purposes, the compiler still knows that this is a number because this is just an alias to another property. But this is a simple example. I mean, we're just putting an alias to a primitive. We can do that for more complex objects. Let's say here we have a create user function that gets a person. And the person, it's an object of this shape. It has three properties. And we could use that function just by passing a literal object to satisfy that requirement, that shape. And that will work just fine. But imagine a real scenario, right, where a person has many properties, has embedded objects, so you have a big, messy signatures, and then you need to invoke them this way. So let's create an alias for that particular shape. So here we create a type called person, and then we alias this object. So now we can create a new function that just receives a person type, and then we can do the same. I can declare a constant, in this case, of type person. I fill up the values, and then I can just call it and pass that type there. Well, it's simplified. In Java, we definitely need to create a class for a POJOs or for anything like that. Here you have that flexibility. It's a different way to name a type without going into create an actual class. And you can extend types through using intersection. So here we have a type animal that has a name property. And then we create a type bird that is going to be the intersection of an animal and this additional object. So now bird has both properties available to do that. So you can intersect as many types as you need. And again, everything, unlike JavaScript, everything is type safe. So if I try to do something else, the compiler will complain because hey, there's no property there with that name. Interfaces. Interfaces share some similarities to Java in the way that you can define some behavior and then have a class that implements that interface. But in TypeScript, it's also another way to give names to shapes. So in this case, we are creating an interface called greeter that has a property name and two functions, two properties that are of type function. a function that gets no parameters and returns void. It doesn't return anything. Here in JavaScript and TypeScript, functions are first-class citizens, so you can store functions in a variable. You can pass them to functions. Functions can return functions, and so you can pass. It's like any other type. They're not required. You can have linters. So definitely, I'm not following a standard here. But in your projects, in an actual project, you can provide a linter and say, okay, I don't want this project to use semicolons, or I want this project to use colons. But yeah, they're optional. So we're going to create a function here with a constant that it's an actual function that receives one string, and it will return a greeter. So this is how we specify the return type of a function. And again, I just return an object type, right? A literal object. I don't need to create a class. I don't need to implement this. I just return a shape that conforms to that greeter, and the compiler will be fine. Again, if I try to do anything that doesn't belong, the compiler will scream at me. So I can just call that function, pass a name, and then I can go ahead and use it. And if I run it here, I will see that I can get the functionality there. We can extend interface, just like types, but we use the extends operator or keyword, just like in Java. So here we have an interface animal, bird. We extended with additional properties, and now I have those two things available in my interface. Another cool feature of TypeScript is that I can add properties to an existing interface. So let's say that you're using an interface that you don't have control on. It's in a different package or something. If you redeclare it, so I have it here declared for the first time. If you redeclare it and add additional properties, then those will be added as well. Here I'm adding an optional property, and to make something optional, we just prefix it with a question mark. So optional property, that's why I don't get any errors here. If I make it require, immediately the compiler will show me an error. And now I can assign that value, that additional value, and I can just use the object. So this is a good way to augment interfaces that you don't own. Then it will error out. Wherever you're using it, it will error out.
Is the compiler ignoring the trailing comma on line 32 right there?
Yeah, it's not required. It's just a good practice to have it there. But sometimes I miss it. Also, you can put on your linter, and it will automatically add it for you when you save the file. But yeah, usually it's a good practice to add it, even in the last element. Yep.
How about for like if you need to extend one? I mean, is that even possible?
Yeah, I haven't tried that. Let's give it a try. Probably not, because. Or maybe yes. Yeah. What do you know? Yes. Good question. Yeah, it has to support everything that JavaScript supports, because it's a superset. So it still needs to support all those crazy little things.
Does it enforce the commas if it requires them on every line? Does it enforce having them on the first couple of fields too, or does it ignore that as well?
Where?
So in one of your object definitions, like name after name Merlin, if you remove both those commas, does it?
No, in this case, yeah, because you're passing an object. It's just like a JSON object. Yeah, this one is optional, because here you're finishing the object is the last one, but it's usually a good practice, because that way, if you add something new, an additional property, you don't have to care if you add it or not.
Formatively, that means that the comma doesn't matter at all. That's what's weird about it.
Yeah.
You just use the new line. Or like for truth, or whatever you want to call that, where you can just get, like if you want to
Yeah. This will behave exactly as in JavaScript. So if you want the real truth value, you will say if this equals to undefined. Otherwise, 0 will give you same thing, same falsy type of responses. So yeah, those little fun things from JavaScript, they're still here because it needs to behave the same. So union types, this is one of my favorite features. Like we saw in one of the examples before, union types are just types that can be multiple things, other types. So a simple example here, this is a data input that can be a string, a number, or null. So if I create constants or variables out of this type, it will allow me to add a string, a number, or even a null. But so that's cool, right? But what happens now? How do I use this? Because I cannot do anything with it because it's not. Still, the compiler doesn't know if this is a string or a number or a null. And unless there's some shared functionalities or shared properties between the three things, you cannot do anything about it. And that's where we get to the conversation of type narrowing and type guards that is used by Typescript during its control flow analysis. So let's read this function. So we have a function, a parseDate function, that receives an argument of the type date input. And we know this can be a string, a number, or a null. And the return value is another union. It can return date, an actual date created from that string or number, or a null if we pass null. So that's our business logic. So here we're making a check, a null check. So if the input is null, we cannot create a date out of this. And this is the instance where we're going to return null. So we know just by reading that at this point, null is discarded, right? I mean, the null cannot happen after this. Yep. Yes, because this is not a valid return value. Yes, you cannot say I have a string and I can assign null. You need to be explicit that this can be a string or a null. And here we're going to put something called a type guard. So there are different types of type guards. And this helps the compiler to narrow down the type that we're looking for. So here the type of operator will return the type of a primitive. So here we're checking if the type of input is number, then we know we have a number. And we're going to convert that. We're going to do some operation here. And now we're going to create a date using the numeric constructor of the date object. Now, we already checked for null, we checked for number, we're returning here, so we are not continuing the function. So our last option is that this is a string, right? And I just call the string constructor of the date object. So just the same exercise we just did, Typescript does that during its control flow analysis to narrow down the types. And we can see that here. So if I inspect the type at this point in time, this is still a data input, right? It can be any of those three things. But inside here, since just like we read, we know that we are making a null check here. So this got to be a null. And Typescript knows that. And it will change the type of the variable at that particular point in time to null. So I cannot do anything with it. I just return null. So now on the next step, if it is null, I'm going to return. And Typescript knows that. So now input, Typescript had discarded the null option because it knows that initially we check for that and we return. So now this has been narrowed to a string or number. Same thing will happen here. We are making a type guard check, and now input, we're checking for a number, and now input will be a number. So it will be narrowed to a number, and now I can do number things. And we're returning. So finally, Typescript will know, just like we did when we were reading the code, that this needs to be a string. There's no option because we're returning it. If I remove the return, then this becomes back a string or number because we're not exiting the function. So this can still, at this particular point in time, can be one of those things outside of this block of code. So that's how TypeScript use this type of type guards to narrow down the types, and you don't need to cast or anything. It will just know that based on those checks, this property, this variable has to be of this type, and you can just start using it just like if it is only of that type. We have the operator in that also helps us to narrow down types. So let's say that we have two types, a user and an error. And this is a very common practice in TypeScript to return from a single function, you can return multiple things, right? And maybe you want to express that in your API. You don't want to throw an exception when you get an error. You want to return something more descriptive, something more encapsulated. So I'm going to return an error object in the same function, or a user if everything goes well. So here I'm just going to simulate if I get an ID less than 1, I'm going to return an error. And this is just, again, the shape of an error. I don't need to instantiate an error. Otherwise, I just return a user. So when I call this, at this point in time, TypeScript will say, well, at this point in time, this is a user or an error. You cannot do anything with it until you tell me exactly what it is. So I'm going to use the in operator to narrow down the type. And what the in operator said, you're just checking for a property name in that object. So I'm saying if ID is in this result object, a property called ID, then TypeScript knows, well, there are two options here, and this is the only one that has an ID. So if it has an ID, it cannot be an error. So I will narrow down the type, and I'll change the type to user. So you can start using it as a user. I can extract here the first name. And it knows that in this else condition, since we only have two options, well, in this case, it has to be an error. So it narrows that type, and you can immediately start using it. What about more complicated cases? We have what's called discriminating unions. Here we have three types, one US customer, Canada customer, and an error. Both customers are almost the same, but the US customer has an SSN, a social security property, and the other one, a social insurance property. Yes?
So the type of, you were comparing that to a string, so is the result of like that operator, is that always just returning a string rather than earlier you said type of this like number as a string?
Yeah.
I was curious, like if you did a type of on an instance of like and customer, would it give you like the string and customer?
No, it only works, type of only works with primitives. Yep. So the only difference here is SSN versus SIN, and the third type is just an error, completely different shape. And then we create another type just to make it more readable, our signature, instead of putting the whole type, union type, we can create another type just for readability. And then we're going to simulate some results for each one of the types. Now, one thing that I added here is what they call a tag or a discriminating property. So this is the same property in all the three elements and all the three types. And instead of a type, they have a constant literal, which is unique between the three. So all of them have that. So if I call this function, again, the customer will be of type getCustomerResult, but all those potential options of the union type have this result type. So I can use this result type to narrow down the type. So I'm going to use it here in a switch statement. TypeScript knows this is common between all the three options, so we're good to use it. And if this result type is Canada, immediately TypeScript will narrow down this object to a Canada customer. Same with the US. And by default, it knows that this is the last option, so this must be an error. Yeah, you create your tags and you say the result type, or you can name it anything you want, and then you can narrow down the type based on that. No, but you can use this next thing. So for more complicated things, you can create a type predicate, which is just a function. You can name this function whatever you want. You get that object in that function, and the trick here is the return value. So here we're saying, if customer, so this argument that we're receiving is of this type. And to know that if it is of this type, then you make your own checks. You need to return true or false. So here I'm just making some random checks. I'm checking if SSN is in the customer that I received, if name is there, and let's pretend that only US customers, their name starts with R, just to illustrate that you can do anything you want here to make sure that this is a customer. And you return true or false, and now you can use that. So here again, we get a get customer result, and I'm gonna use my predicate here. And now if this returns true, TypeScript will narrow down to a US customer. Otherwise, in this else, well, I just took care of a US customer, so this still can be a Canada customer or a get customer. Yes? Type of, it's okay to be used here in TypeScript. As the casting, yeah, it's not a good practice. I was just illustrating another option to narrow down the types. But yeah, you usually don't use as, you usually use tag properties, discriminating properties, or predicates. I think in 85% of the times I just use a tag if I own that object, that type, right? Because if these types are coming from somewhere else, then you might as just create a predicate function to narrow down the type. But usually when I'm creating the API, I just tag my types that are going to be part of a union, and then I'm good to go. Yep.
In your more primitive examples, why can't it infer the type from the return value of the function? You had error and customer, and none of their properties overlap, right? So you would think the return value when you were creating, you would be able to infer from that. So you have to type check it again.
This one?
No, it was your first example, I think, the more primitive one with the error and customer, or user and error.
Okay, this one?
Yeah.
Yeah, here on the else, it's just an error.
Right, but I'm saying the get user function, shouldn't it be able to infer the type from that?
Well, the type is user or error. It's a union type. If you see it, at this point in time, you're just passing an argument, and TypeScript doesn't know what you're going to return, if you're going to return a user or an error. So at this point in time, the result is a user or an error.
What he was trying to say is like, well, in the return you have like ID, net name, and L name, so like the shape of that object, like which of those two, user and error don't have anything in common. So by virtue of returning an object that has that shape, could it possibly just infer which type of those two it was that got returned?
Yeah, but this is going to be on runtime, right? You don't know what you're going to get. Okay. Yeah, so just like we have unions, which are types that can be one thing or the other, we have intersections that are it's just the merge of both things. So I have a type swimmer and a type runner with a single function as a property, and then I can create a new type called swimmer and runner, and it's just the intersection of both objects. So now a swimmer and runner can have both things. So it's instead of one or the other, it's both at the same time. Okay, generics are pretty similar like in Java. I mean, you can create generic classes, generic functions, but I just want to show a cool thing about this thing. So let's pretend we have a get property function, and what I want to do is to receive any object and extract one property that I'm going to pass as a second parameter. So I'm going to pass a property name as my second argument, and I'm going to extract the property with that name from that object, and it can be any object. So one way to do it without generics is just to use the any, just like we have object in Java. So I can receive anything, and then I'm going to try to extract that property name. In JavaScript and TypeScript, you can access properties from an object, just like with the keys values, just like in a map or an array, and you can get that. So pretty simple, but multiple problems here. Because one, the return value of this will be any, because we're not providing any information to the compiler, right? So maybe that property that we extracted is a number, maybe it's a string, but it will be any in this case, and we don't like any. We want type safety. Another thing is that I can pass any property name, right? I mean, I can say anything that I can pass any string, and it might be a property that doesn't exist there. So now I'm going to return undefined, and I need to make a check for undefined, so it just complicates my code. But there's a better way to do that with generics. So here I'm just creating two random types with some properties, and then I'm creating two actual objects of those two types. And this is the generic version of that function. So one, I want to make the first argument generic, so I'm just creating a generic type, and that's going to be the type of my object. But this is the cool part. The key, the name of that property that I want to extract, I'm going to use a couple of operators here. One is just like in Java, we can extend, make sure that our generic type extends something, so we can narrow that down, right? We cannot just accept anything, we narrow that down. But the key of operator will return me a union of the names of every property in the object. So if I'm saying that this is getting me a union of all the keys, and I'm saying that the key needs to extend that. So how does that look like now? I can call the person, pass a person, say the age. One cool thing is now Typescript knows exactly the only strings that I can pass. If I try to pass something else, that doesn't exist. And this is a generic function. Same thing, now I'm passing a conference, a completely different object, and it knows exactly what are the allowed property names that I can pass. I cannot pass something else, so I don't need to check that this is going to return undefined. Another benefit, now these things will be typed correctly. Attendance is a number, person date of birth, it's a string. Person, I changed it to, obviously I did that to demonstrate that it changed the type. It's a string, yep. First of all, you will need to, if an unknown property on that shape, you mean?
The function that you define, the get property.
Yeah. On the first one, it's any. If I do unknown, it will not allow me to use it. So with any, it lets you do anything. It doesn't make any checks. But unknown, even though it accepts any value, it will require you to narrow down the type. So that makes you avoid a lot of issues. So for example, here I can say, well, I need to narrow down the type before extracting a property. So that's the purpose of the unknown.
And at the bottom where you were saying the generic one, that K extends K of D, I would think like K is K of D. So if you're saying like K of just returns like all the possible keys, right? Like would in work there? Is it got to be extended?
In just returns true or false, right? Okay, I think we're good on time to finish this couple more lessons here. Utility types. Utility types in Typescript, it allows you to transform types, to generate new types from other types. And this is really, really helpful because it cleans up a lot of unnecessary code and checks. So let's pretend we have a blog post. I'm creating an interface and it has these properties. The first one, we can add access modifiers. So for example, in this one, we're saying, hey, this is a read-only property of type number. This will be the ID of our blog post. We have a title. We have a content that is optional because maybe we can create the blog post without any content at first. Then we have a status, which is a union of literal strings. And that's why this is a case where you might add an enum, but this is more practical. And if I need to reuse this, I can just put an alias, create a type alias, and then I can use this anywhere. So it's a string, but it will only allow me to add any of these three values. And then we have a regular string for the category. Let's create a new post function that takes a blog post. Then it will store it on the database or call another service to store it or whatever. Let's try to use it. So, and another requirement for me is that, well, the blog post doesn't have an ID when it's new. So I need to generate that somehow, and then it will get automatically assigned. And also my business requirements are that it will, when you create a blog post, it needs to have a default status of new. So you will actually make it as a new status initially. So what happens here when I try to use this? Well, I don't want to the compiler will complain because blog post has some required properties, right? It has a ID, which is required, a title, well, I'm passing the title, the category, and the status is also required. But I don't want the user of this function to pass me those two things because ID will be automatically generated, status will be, I need to make sure that it's set to new. So what are my options here? Do I create a new interface, another shape that only has those things and make them optional? Do I specify every single property here in my signature? I mean, there are multiple options, but I don't want to write more code. So let's rewrite this using utility types. So utility types create another type from an existing type. So here I'm using the utility type omit. And it will take a blog post object and it will remove the properties that I'm specifying here, and it will give me a new type. So now this type, if I inspect it, it only has title, content, and category. It doesn't have ID, it doesn't have status. So now I can generate that. I don't need to create a new type. I don't need to make any changes. I want to make sure. I mean, there are many things that we can do, right? I mean, I can set the ID to 0 and I can ignore it, but that's just error prone and it's not clean. What about if we have a get read only post? I want to return a post and I don't want people to mess it around because it's going to be displayed on the screen. I don't want someone by accident changing anything. So I want to make it read only. But blog post, the only read only property is ID. Everything else is mutable. So what do? There's another utility type that will create a new type out of blog post, and it will make everything read-only. So now if I do that and I get I call it, if I try to change anything, it won't allow me. What about an update? An update, I want to call update, and I just want to pass the things that I want to get updated. I don't want to, but everything is required, right? Except for content, everything is required. And I just want to get the things that are going to be updated. So again, there's an utility class called partial that will make everything optional. It will create a new type out of blog post, and every property will be optional. And I can grab multiple, right? I mean, I can make a partial that will make everything optional and say, okay, I'm going to omit this other property that should never get updated, right? Like a timestamp or something like that. So now I can just pass the things that I need to pass. There are many other utility types like that, and they're super convenient. I mean, reduce a lot of the code that you need to write. Okay, so this is the last one we're going to do today. String template. This is a JavaScript thing. But, I mean, if we want to concatenate values with strings, I mean, we can use the typical concatenating with plus sign. That works perfectly fine. But there's something called a string template that we wrap our string with backquotes, backticks. And then we can interpolate values, expressions, not only a single variable where we can call a function or whatever, with the $sign and curly braces. So Typescript will replace these things. And we can make it multi-line if we want. That's completely fine. So if we run this, we see the first one, which is your regular concatenation, and then the second one. So this is very typical if you're using JavaScript. Now, let's look at template literal types. So this is one example of a type that is a union of literal strings. Let's say that I want to create a string element, but I only allow these particular strings. So I want to type safe that. So I create this union, and now Typescript won't allow me to set up any string but the ones that are part of that union. But what if, let's add something. Well, this is hard to maintain, right? What if I want to add Kotlin? Because we can also learn Kotlin here in Devnexus. So there's another way to do this with template literal types. So let's create a union type of type language. Let's remove this one for now. And so another union type for the date. So now I'm going to create a string template, which is instead of a constant, I mean a variable, I'm going to create another type, but I'm going to use a string template, and I'm going to put interpolate those other types. So what Typescript will do is that it will create all the permutations for me. So now it will create all those combinations, and this is the only type of string that I can assign. If I try to do something else, the compiler won't allow me. So now I can add back Kotlin, and again, TypeScript will do the hard work for me, and now I have Kotlin also in the list with all the days. And an additional one, and again, this is also present in JavaScript, but I think it's pretty cool, the tag template literals. So again, this is our simple string template. But let's say that we're doing this in a lot of places, and we want to do some pre-processing of this string. We want to add, let's say that we're spitting out some HTML, and I want to highlight every single placeholder that I'm adding. I wanted to wrap it in HTML tags, so it looks highlighted on the screen, right? So this is the end result that I want to have. So there's tag template literals. The tag is basically just a function that has this signature. Here in this function, we're getting a template string array, which are all the fixed string literals here. And then we're going to get the actual values, the process values. So let's say that here I'm calling a function. That function returns a language name. I'm going to get that language name in that second array. So I can do whatever processing I want here. Here I'm iterating through each one of those, and I'm just wrapping those values in strong tags. And now if I call this, well, this is without my tag. So if I run this, I will just get our typical a string, but now I'm going to tag this with this function, and I'm going to get a different result, the result that I was looking for, which is wrapping those things. This is, I mean, a really small example, but this is very powerful. There's a library to connect to use Postgres from JavaScript or TypeScript, and you can create those tag functions. They have the tag SQL, and you pass a template, and you interpolate all your values, and internally it will clean up from SQL injection, it will execute your query, and you will get back your results. So this will give me my list of results based on this query that I'm passing. So very powerful things that you can do if you're building a library, if you want to clean up some of the some reusable type of functionality. And I cannot believe I finished on time. Is there any questions? Thank you. Yep. You can definitely use JavaScript libraries. There are two ways. I mean, right now, most of the JavaScript libraries, the most popular, include types definitions, because when you're using them on TypeScript, TypeScript needs to know what the types, which JavaScript doesn't have, but you can add them, and most of the libraries are being added. So unless it's not something really used, you probably will have a hard time to find the types, but you can create them on your own. You can download a package and add the types yourself, but usually the most common ones they already have types, and you get that type safety benefit.